Hi everyone, welcome back. Today we're going to take a deep and practical look at connecting identical transformers in series and in parallel, and more importantly, how voltage, phase, current, and isolation really behave in real conditions. We are using two identical transformers with 220-volt primary input. Each transformer has a center-tapped secondary winding, 12 volts from center to one side and 24 volts across the two outer terminals. For clarity and accuracy, we only work with the 24-volt outputs. Using identical transformers is critical. Different turns ratio or power rating can cause circulating currents, overheating, or unstable voltage. We connect one output wire of the first transformer to one output wire of the second transformer. Then we measure the voltage across the remaining two wires. If the measured voltage is close to double 24 volts, around 48 to 50 volts, this confirms a series connection. Now we swap one of the output wires. When the measured voltage drops close to zero, this means the transformer's outputs are 180 degrees out of phase. In opposite phase, voltages cancel each other instead of adding. This is not a fault, it's a phase reference issue. By matching the correct phase wires and connecting them together, the transformers are now parallel on the output. Voltage stays at 24 volts. Parallel connection increases current capability, not voltage. Parallel transformers must be identical in voltage, phase, and impedance. Otherwise, internal current circulation can damage them. In the next test, the secondary outputs are connected together, but only one transformer receives 220 volts on its primary. On the primary of the second transformer, we measure about 169 volts. This confirms electrical isolation from the main supply. Energy is transferred magnetically, not directly. Even after swapping the secondary wires, the voltage remains around 169 volts. Isolation is preserved. Now we power the second transformer instead. The voltage measured on the first primary rises to nearly 200 volts. This shows voltage interaction through magnetic coupling. Series connection increases voltage. Parallel connection increases current. Phase alignment is critical. Isolation improves safety but affects voltage behavior. If you enjoyed this video and learned something new, don't forget to like, subscribe, and support the channel.